In this unit, we are going to discuss one of the important module of operating system called file system. So this, as per your syllabus, is unit 5, the last unit. File system is supposed to be what is called visible portion of operating system. Visible portion. Why is it called visible portion? Because if you see the various modules of operating system, none of the modules of operating system are visible. You cannot see process. You cannot see memory manager. You cannot see process deadlock handling. So as such, any module of operating system is not visible. The only part of operating system which is visible to human eye, which we can see as a user, is file. You can see the contents of file, you can see the contents of directory. Okay, so in that regard we call file system as visible portion of operating system. Now what exactly is file system meant for? What is the purpose of it? Where does it reside? Let us understand by means of this diagram. Okay, here I have CPU. Maybe on this CPU we run some process, and here we have the disk, secondary storage, auxiliary storage. Now you know it very well, everybody knows that before using the secondary storage like hard disk or pen drive or DVD or anything, the disk has to be formatted with some file system, is it not? Like most of the prominent file system that we use for formatting is NTFS or maybe FAT32. Several file systems we use, you generally everybody is aware of it. So what exactly is the role of the file system? The file system is meant for a software meant for organizing the data on secondary storage. I would say, in my own terminology, file system is like putting infrastructure onto the disk in order to store the data in the form of files. Without putting the infrastructure, you cannot organize the data effectively and efficiently. So essentially, file system is a software for managing the secondary storage, is it not? And this file system is part of your operating system. So file system is one of the module of operating system. Just like we have process manager, memory manager, file manager is meant for managing all secondary storage devices like disk, pen drive, DVDs and so on. It is just like putting some infrastructure onto the disk in order for better storage and better retrieval. So file system is essentially a software for managing data on secondary storage devices. So managing means basically storing the data, retrieving the data, organizing the data. So for all these purposes we make use of file system. I hope you got an idea as to what exactly is file system. So in this chapter our objective is to learn the design and implementation aspects or issues of file system. But before we start our design and implementation aspects, it is essentially that we first understand some interface, file system interface. What kind of interface do we programmers or users essentially expect from file manager or file system? So in this file system interface, our objective is to basically learn some important fundamentals like the concept of file, the concept of directory and so on. So that should be understandable to us, is it not? So let's have a review with regard to first the concept of file. What is file? See, the definition of file everybody is aware of. Everybody has been using the term file since your first year of engineering. Am I right? Everybody knows that. So let's try to formalize the definition. You might have studied about files in programming. You might have studied about files in DBMS and so on. So here we'll make a formal definition. File is a collection of logically related records of an entity. Entity means some entity, like maybe entity could be students, could be faculty, could be anything. You might have studied about that in database. Collection of logically related records. It is not that in one file we kept all records. No, records of employees. So record file of employee records, file of student record, file of book records, etc. Collection of logically related records of an entity. Now this is a general definition. From the implementers, operating system developers, operating system programmers perspective, file is considered as an abstract data type, ADT, abstract data type. Now being an abstract data type, file will have its definition, file will have its representation, how do you represent the data, and being an abstract data type, files support a well-defined list of operations. Plus, file will also be associated with a well-defined list of attributes. These are the things that we need to study with regard to files in this particular chapter. So let's take up one by one. Definition we have seen just now. File is a collection of logically related records. Just now I said definition is a collection of logically related records of an entity. That is the definition. Now coming to the representation. How do you represent the data in the file? How do you represent the data in the file? That we have to see. So let's study about the representation. Okay, so how do you represent? That means when we organize the data has to be organized in certain fashion. So how do you basically represent the data? So here let me write representation. Essentially there are two representations of the data in the file. One is what do you call flat structure. You represent the data in the form of flat structure, means you just store the data in the form of series of records. No organization, just series of bytes, not records. Let me rub it off. Okay, series of bytes. Okay, series of bytes. No boundaries of records. The other is called record structure. The other is called record structure, the other representation. Here we store the data in the form of records of some employees, some students, records of entities. An extension to record structure is called hierarchical structure. This you might have studied in databases. Hierarchical, which is also called tree structure. Maybe in the form of B trees or B plus trees and so on. Hierarchical structure. So every file will have its own structure, with either flat structure or record structure, or maybe an extension of record structure. You call it as hierarchical structure. So our definition is over, representation is over. Then what come next? Everybody is aware of operations. Don't we perform certain operations on file? Yes. So what are the operations that we perform on file? Everybody is aware of. What is the first operation? We create the file. Create. Then if a file is already existing, we open the file. Then if the file is opened, then we perform operations like read, write, append, seek to a particular record, then modify, truncate, and others. Then subsequently we can have other miscellaneous operations like copy, rename. Everybody is familiar with all these operations, am I right? Rename, and then move the contents of file, then eventually close the file and then delete the file. So these are some of the operations which we generally perform on files. Okay. Then the next important attribute, next important characteristic or parameter associated with file is called file attributes, an important one. File attributes. Attributes means properties, characteristics. So what are the important attributes of the file that are associated with the file? First attribute, maybe a file is associated with a name. Every operating system will have a convention for assigning names to the file. Some operating system will put a limit saying that the name cannot be, say for example, more than 8 characters, more than 16 characters, something like that. Some limitation on the name, or some operating systems say we don't have any limitation on the name of the file. Some operating system is going to put some limitation that a file name cannot start with so and so character, has to start with only these characters and so on. So therefore name is the first attribute. Then identifier, file ID. When you open the file, operating system would associate an identifier with the file. Then we say type of file. What type of file? Is it a regular file, special file, document file, multimedia file, archive file? Every file will have a type. Then location. Where is the file located? Right? On what part of disk, the directory where the file is located. Then the size of the file. In kilobytes, megabytes, gigabytes, we measure the size of the file. Then we have protection information. File is readable, writable, executable. Okay, can we delete it or not? Protection information. And then we have date and time stamps. Time and date stamps, like time of creation, and then date of creation, time of last access, date of last access. You can generally see all these attributes of the file. And then user information, we generally call owner. Who is the owner of the file? Okay. Like that, there can be other several attributes. So different operating systems may have different set of attributes associated with a file. These are called general attributes. Then we also have some location attributes, which I told earlier. Location attributes in the sense that every file has to be stored on disk, and the disk space is organized in the form of blocks. So therefore we are going to discuss about this later point of time. I would here only introduce that concept to you. Disk blocks in use. Now disk block is a unit of disk space where the file is going to get stored. It is stored in the form of blocks. So what blocks are in use is also attributes of the file. So these are general attributes that a file is associated with. I hope you get the point. Just like this concept is just like your process attributes. Remember, every process we said is associated with several attributes. So like process ID, and then process state, process type, and so on. So like that, file is also associated with these attributes. Just like if you remember, we said earlier, process attributes are stored. If you remember when we discussed process management, process attributes we said are stored in PCB. So like that, file attributes are also stored in a table. So the place where file attributes are stored is called FCB, file control block. What is it? So let me write it here. What was PCB? Process control block. So like that, this is called file control block. So what do file control block contain? File control block is going to contain the attributes of the file. So what are the file attributes? Like name of the file, owner of the file, date and time stamp, the one which I presented earlier, that is called FCB. Now, FCB is known by different terms in different file systems. Like in Unix file system, Unix or Linux file system, FSS file system, file control block is given a name. You have to remember this for general information, and later point of time also I am going to elaborate on this inode. So what is FCB in Unix file system known as? It is called inode. Okay, I stands for index. We'll talk about that later. Whereas in the case of Windows file system, okay, it is given a name called directory entry. It is called directory entry. We'll talk about directory and the directory entry concept shortly. Just I'm introducing the terminology which you need to remember. So again, I summarizingly tell you everything what we discussed so far. We first define formally what is a file, collection of logically related records. File is an ADT. ADT means it has its definition, representation, operations, and attributes. What are the representations? We said popular representations. The popular representation is flat structure or record structure or hierarchy. An extension of record is called hierarchical structure or tree structure, like B trees, B plus trees, which you had studied in databases and data structures. Now, files support a well-defined list of operations. I don't have to tell you what are the operations. You are very well aware of it, like creating file, opening a file, reading, writing, appending, seek, modify, truncate, and so on. Okay. And then the file is associated with several attributes, properties like name, identifier, type of file, location of file, size, protection, time, date, and so on. Okay, these are the different attributes. These attributes of the file are kept in a table generally called FCB. Just like process attributes are kept in a table called PCB, file attributes are kept in a table called FCB, file control block. Now, file control block is known by different terms in different file systems. Like in Unix, it is called inode, and in Windows, it is called directory entry. Now, before I introduce you to the concept of directory, I just talk about various types of files. Okay, types of files which we generally encounter. Generally, we say special files, and the other is called regular files. Special file means like device driver files. These are not used by users, device driver. Now, under regular, we may have like executable files, .exe, or you may have object files like .obj, or you may have source files like your C program file .c, .cpp, okay, and so on. Then we can have batch files. So you can have batch files, then you can have text files, okay, and then word processor files, and even you can have library files, archive files we also call it as, library, and then archive like with extension .tar, .rar, archive, okay, print files like your PDF, PS, etc. Multimedia files, multimedia files. So I can have different types of files. Different operating systems will support different types of files. So these are all known things to you. This is generally called file system interface, means what kind of interface do we expect from the file manager with regard to the files. Okay. So I hope the concept of file is clear to you. So if this is clear to you, then we can proceed with the next aspect on directory. Okay. So in the next video, we'll see what is directory, what are the operations on directory, and what are directory structures. Okay, right.